Right, we're going to do some hypothesis testing with the normal distribution. So, we have what we think is the mean for the whole world, the population. When we test, we can test a few things and get their mean, and we can see whether it's a good enough fit for the population mean. And the way we do this, we have to take into account the size of the sample. The bigger the sample, it should be closer to the population because you've got more of the population. If you've only got a very small sample, then there could be quite a lot of variation. So the way we deal with that is, instead of having our normal distribution with mu and sigma, we adapt the variation by dividing by the sample size, so that the bigger the sample, the closer we would expect our sample to be to the population. Now, writing the hypothesis is very similar to when we did binomial hypothesis testing. So we always have a null hypothesis, which is that mu actually equals the value, and we've got an alternate hypothesis, which is that mu isn't that, and it might be less than it, it might be more than it, or it might just not be it. Then what we test is our mean from our sample, and we see what value we get out. So, because we're testing the means, we're going to use this distribution, not the standard normal distribution. Right, it's easiest to do it in examples, so let's start with an example. So it's normal distribution, standard deviation 3, and the claim is that the mean is 60. So the claim is that it's normally distributed with a mean of 60 and a standard deviation of 3. However, the trading inspector thinks the company is overstating. So mu, our null hypothesis is that, yep, the mean really is 60, but the trading inspector thinks actually it's less than 60. So he samples 16 cartons and gets a mean value. Now, is this good enough? Because it's obviously less than the 60, but are 16 cartons enough for us to say, yeah, the whole lot is less than 60? So we're going to, instead of dealing with our normal distribution for the whole population, we're going to do the conversion to just our sample, which means that we divide the variance by the sample size. Then, very similarly to our binomial test, we want to see if the mean, and we take the inequality from the alternate hypothesis, so in this case less than the mean in the question, and we find the probability of that happening, and we compare it to our significance. So we've got a normal distribution going from -1000 up to 59.1. Sigma, now remember we want the square root of this, so it's the square root of 3 squared over 16, and the mean is 60. Now the probability of that happening is 0.115, which is greater than 0.05, so it could just be happening by chance. There's a good probability it's happened by chance, an 11% probability it's happened by chance, so therefore we can't reject H0, insufficient evidence. to reject H0, therefore cannot uphold the complaint. Okay, let's look at another example. So this time we've got volts, and they're normally distributed with a mean 0.580 and a standard deviation 0.015. We want to see if the mean diameter has changed. So our null hypothesis is that the mean really is what they said, and our alternate hypothesis is that actually it's not that value. So we're going to have to do two tests. We've got to do a greater than test and a less than test. So the distribution we're going to test is for the sample. So we need to adjust the variation by the size of the sample, and we've sampled 50 volts. Now this time they haven't told us what the size is, but it's asked for a critical region, so we need to find what value gives me a probability that is less than. Now I've got a two-tailed test because it's not equal to, so I need to halve my significance, so 0.005. So to find this is a inverse normal. Inverse normal we can't do greater than, so we need to convert it to less than and 1 minus. Oh no, it should be greater than. So the area is 1 minus. Sigma is the square root of 0.015 squared over 50. And the mean is 0.580. And it tells me that the K value is 0.5855. Let's go full sig fig this time. So if it's bigger than that, it's changed. Or, looking at the other end, .5745. So the critical region is if it's less than 0.5745, the mean has changed, or if it's greater than 0.5855, then we can conclude that the mean has changed. So they've actually said it's 0.587. 587 is in the critical region because it's greater than that value. So there's sufficient evidence to reject H0. So our conclusion is that the mean diameter has changed.